Hi my dear students, this video is a continuation of the topics we have already discussed in the chapter solution. I think you remember the first part of the chapter solution, that is topics concerning concentrations of solution and different methods to express concentration of solution has been finished. And this video is a continuation of that topic. Anyway, I recommend you to refer the textbook. In this session, I would like to discuss two topics which are connected together. They are solubility and Henry's law. Solubility is a term you have been introduced in +1 chapter equilibrium. I think many students have lack of clarity about the topic solubility. Therefore, I recommend you to read +1 part again and you follow this brief discussion also. Let us see what is solubility first. You see the board. Okay, dear students, solubility is the maximum amount of solute. You underline that word, maximum amount of solute that can be dissolved in a given amount of solvent at a given temperature. When temperature changes, solubility changes. That is why temperature is specified here. Now, unit of solubility. Solubility is expressed in molarity, molality, mole fraction, gram per milliliter, gram upon liter. Simply speaking, directly speaking, solubility is nothing but it is the concentration of that species. This understanding is very important. Okay, what is the meaning of solubility? Solubility. Imagine you have a container with water 100 ml at 25 degrees centigrade. Now, you keep on adding AgCl. Suppose AgCl like this. This is coming. You add 1 gram. All AgCl dissolved. Now you plus 0.5 gram. 0.5 gram. You know what happened? Plus 0.5 gram, some more dissolved. some more dissolved, but what you noticed? Okay. Now you can say your solution is saturated. What I did 100 ml water at 25 degrees centigrade. I add a small amount HCl, completely dissolved. Again small amount, dissolved. Again small amount, dissolved. Again added, total I added 1.5 gram. I got some undissolved HCl. Undissolved HCl in the bottom of the beaker. Now I can say this is a saturated solution at 25 degrees centigrade. If I filter undissolved, I can say how much is undissolved. Total I added 1.5. Therefore I can say how much is dissolved. Now there is an equilibrium. Please understand that. This is solid, this is aqua, this is sulfur. What does this mean? Is this HCl I added? No. This is HCl undissolved. This is settled one in the bottom of the beaker and it is in solid form. This represents undissolved HCl. This represents dissolved Ag plus and dissolved Cl minus ions. And there is an equilibrium between them. You learned all these things in +1. Okay, I just recollect. Okay, this is all about the solubility. Now, factors affecting solubility. Factors affecting solubility. One, nature of solvent. Second, nature of solute. Third, temperature. Fourth, pressure. Condition, gaseous only. In 1 and 2 we can say together like, dissolve, like. What is the meaning? Sodium chloride in water. Sodium chloride can be dissolved in water. Okay. But sodium chloride not in benzene. Benzene is a solvent. Benzene is a solvent. Fine. Okay, you cannot dissolve the sodium chloride because it is polar. This is non-polar. This is also polar. You take naphthalene that can be dissolved in benzene. Naphthalene can be dissolved in benzene because non-polar, polar. That is like dissolving like. Next is temperature. Temperature. Effect of temperature. Effect of temperature. Okay. First point, very very important point. When gas is dissolved in liquid, comma, if temperature increases, solubility of gas decrease. Whatever the gas, its solubility will decrease when temperature increases. We know in the hot water amount of oxygen is less. In summer season, we are recommended to keep soda water in the refrigerator. You know why? If you keep outside, because of higher temperature, gas will try to escape from the solution. That will make a push of the cap and sometimes it will be exploded. Fine. This is the general nature of every gases. Okay. Now next. If solid dissolved in liquid, temperature depends upon Le Chatelier principle. Okay. You know, ammonium chloride, sodium hydroxide. Ammonium chloride and sodium hydroxide. Here it is endothermic. That is delta H positive. It is exothermic. That is, dissolution of ammonium chloride in water is endothermic. It absorbs the heat from outside. That is why when you dissolve the ammonium chloride in test tube, you touch the sides of test tube. Side of the test tube, you will feel cooling. Because that has absorbed heat from the surrounding. Therefore, surrounding outside the test tube will be felt, sensed cool. But if you dissolve sodium hydroxide, reverse happens. You will feel heat. Test tube will be hot. Okay, in this case, when temperature increases, solubility increases. But here temperature increases, solubility decreases. Particularly at the saturation point. Therefore, please note down this point. Very, very important. In the case of exothermic, temperature increases, solubility decreases. In the case of endothermic, temperature increases, solubility increases. Le Chatelier principle. Okay. Now, effect of pressure. Effect of pressure. This is explained by Henry's law. What is Henry's law? Says, suppose you have water, a bottle water. You want to fill carbon dioxide. Carbon dioxide. Okay. The carbon dioxide, you want to fill the carbon dioxide. Okay. You want to fill the carbon dioxide here. This is dissolved carbon dioxide. The amount of carbon dioxide dissolved directly proportional to pressure of carbon dioxide above the solvent. How much pressure, how forcefully you are applying the carbon dioxide to the surface of the solvent, that much gas will be dissolved. Here at given temperature, that's very important, given temperature. This is a Henry's law. Amount of carbon dioxide dissolved directly proportional to pressure of carbon dioxide above the solvent. Yes, if you have a soda maker in your house, how much carbon dioxide you are going to dissolve in the water depends upon how much pressure you are applying through the machine. Fine. You can define the law like this. This is a definition. The solubility of gas, the solubility of the gas in a liquid is directly proportional to pressure of the gas above the solvent or solution at a given temperature. Now that is how much pressure you are given directly proportional to solubility. Solubility, I said to you, solubility can be expressed in mole fraction, molality, concentration, any terms. NCERT has used a mole fraction, therefore we can use that. Mole fraction. Okay. What is P? P is pressure of the gas above the solution. What is X? Mole fraction of the gas in the solution. Now proportionality constant is removed by a constant X. What is KH? KH is called Henry's constant. Okay. Yes. Henry's constant KH depends upon nature of gas. You know what is the relation between KH and X? Solubility. That is, you keep the KH here. KH inversely proportional to X. If you bring to here, KH is equal to P by X. What is this meaning? This is nothing but solubility. That is, if KH value of a gas is higher, its solubility will be lower. Very important point. KH value of a gas is higher, its solubility will be lower. If KH value is lower, solubility will be higher. I give you two gas, KH value, helium and oxygen. Which is more soluble in water, whether helium or oxygen? You know oxygen. Therefore, You know, its KH is 146. This is 46. Now you take ammonia. Whether ammonia or oxygen is more soluble? Usually ammonia. Therefore, KH value order. KH value order. Ammonia less than oxygen less than helium. More the solubility, less the KH value. Okay, these are very important points. We can solve two questions. First question. H2S has solubility. H2S has solubility 0.195 molality at STP in water. Calculate its KH value. KH value. Our relation is P is equal to KH into mole fraction. This is our relation. P is 180 because at STP pressure is 180. Now you know what is X, but you have given molality is 0.195. Molality means number of moles of solute dissolved in 1000 gram of solvent. 1000 gram of solvent. Here solvent is water, its mass is 1000 gram. Okay? Therefore, number of moles of water is 1000 divided by 18, that is 55.55. Number of moles of solute. Number of moles of solute. What is the solute here? H2S. What is its number of moles? This much. Because molality this given means this much mole dissolved in 1000 gram. Therefore, number of moles of H2S is 0.195. Therefore, what is the mole fraction of H2S? That is the mole fraction of H2S. Number of moles of H2S divided by number of moles of H2S plus number of moles of water. Okay? This is almost 0.0035. Okay? Now you got the mole fraction of this. Now you can calculate KH. Therefore, KH is equal to P 1 by 0.0035. It's almost 282.80. 282.80. I think this problem is okay. Now we can solve next question. Second question. KH of carbon dioxide in water is 1.67 into 10 raised to 8 Pascal. Calculate the quantity of carbon dioxide in 500 ml of soda water at 2.5 atm. Yes, Henry's law constant is given. That is, you have a 500 ml water. Above that, carbon dioxide pressure is 1.67 into 10 raised to 8 Pascal. How much carbon dioxide dissolved? What is the quantity of carbon dioxide dissolved? Pressure is given, Henry's constant is given, pressure is given 2.5 atm, Henry's constant is given, kH is given, pressure is given, quantity as asked. Therefore, first, this is our relation, P is equal to kH into mole fraction of carbon dioxide. Mole fraction of carbon dioxide is nothing but 2.5 divided by 1.67 into 10 raised to 8 Pascal. This is atm. Therefore, it should be either you convert this into atm or this into Pascal. You can do both. Okay. You know, 1 atm is, if you want to convert this into Pascal, you just multiply it with 10 raised to 5 Pascal. That's better. Now this is also in Pascal. Okay. Therefore, the mole fraction of carbon dioxide is nothing but 1.51 into 10 raised to minus 3. Okay. This is a mole fraction. This is equal to number of moles of carbon dioxide divided by number of moles of water plus number of moles of carbon dioxide. For convenience, this is taken as number of moles of carbon dioxide divided by number of moles of water, because this value is very, very small. That means this numerator is so small, therefore that value here can be neglected. Therefore, this is equal to 1.51 into 10 raised to minus 3. Okay. Now you have 500 ml water. 500 ml water means its density is 1 gram per ml. Therefore, it is 500 gram. Therefore, number of moles of water is 500 divided by 18. 500 divided by 18. That is 27.78. You know, 500 ml water means 500 gram. Because its density 1 gram per ml. Therefore, number of moles of carbon dioxide is equal to 1.51 into 10 raised to minus 3 into 27.78. Okay. Now, what is the mass of the carbon? This is the number of moles of carbon dioxide dissolved. Mass of the carbon, number of moles of carbon dioxide means weight divided by 44. Mass of the carbon dioxide divided by 44, molar mass. Therefore, mass of carbon dioxide is equal to 1.51 into 10 raised to minus 3 into 27.78 into 44. What is the final answer? Let us see the final answer is 1.85 gram. This much mass carbon dioxide dissolved. That is the quantity of carbon dioxide. I hope these two problems, numericals, are Clear you? If you find any difficulty, please contact me. I will support you. Thank you for watching.